Hello, everyone. I'm going to talk about an ongoing project, which is my master thesis, and it's related to wetlands and remote sensing, with the aim of improving the monitoring of wetlands in Sweden by the help of satellite data, open source satellite data, and the free accessible online platform of Google Earth Engine. And regarding the wetlands, as we may know, they are valuable ecosystem for the flood risk mitigations, for biodiversity, and we can see from the background image that we have a complex ecosystem. We can see the lakes, the forests, the grasslands, and of course the monitoring of this sort of ecosystem is not easy because probably some sort of water is hidden below this vegetation that we can see from the image. So because this is the first presentation in the remote sensing session, I'd like to go through a brief introduction to the remote sensing and the satellites. It's going to be very simple. So the two major methods that we use in remote sensing is radar and optical. As we can see, radars are emitting the microwaves to the Earth and gather the backscatter from the Earth. But what we have with optical sensors, they only gather the backscattering visible lights and near infrared lights that coming back to the sensor. So there is not any emitting waves from the optical. So one of the limitation of the optical sensor is that when we have the clouds or we don't have the sun, we couldn't gather anything. So it's limited to the sunlight and no cloudy day. But what we have with radar, we can have somehow penetration into the canopy. But with optical sensors, we only have data about the surface of the object on the Earth. So when we use the radar, we can somehow go through the vegetation and detect the water which is below the vegetation. For example, with double bonds reflection, we can detect the water that's hidden under the vegetation, and we couldn't see that with the optical because it's only the reflection from the surface. And what's the relationship between the remote sensing and this research? It comes up when we go through these questions. We wanted to improve the water extent delineation in our wetlands, so we needed to also detect the hidden water below this vegetation. So we go through different type of remote sensing, radar and optical, and we somehow compare these two sort of methods to see what we can gather to improve this water that's not visible with the optical sensors. Going through the study area, we selected the Ramsar wetlands, which are the wetlands with international importance. In whole Sweden, we have 68 wetlands. We can see the coastal wetlands with blue colors, and also the red colors are the inland wetlands. But our main focus was on the wetlands that, based on the national land cover of Sweden, they includes more than 10% of open wetlands, which in these open wetlands we can use the satellites efficiently. So as a case study, we selected one of the wetlands, which is somehow near Stockholm, that gave us the opportunity to go there and gather some field data from there. And the other features of these wetlands is that it's temporarily flooded during the different seasons. From spring until the end of summer, we have flooded areas in the wetlands. So we can use the satellites and detect these changes and to see what's going on in this sort of wetlands. Another specific feature of this wetlands is it's a mixture of lakes and the vegetation, and we can see the interaction between this water and vegetation. And also, of course, as most of the wetlands, it support the rare species inside this wetland. If you look in depth into one of the large lakes in this wetland, we can see with optical, as I mentioned, you can see that we only detect the surface of the vegetation that's inside the lakes, but with radar, we can somehow penetrate into this vegetation and detect the water. So if we can somehow mix these two methods of remote sensing, we can reach another additional data that give us, okay, if this is the boundary of our lakes, we have some vegetation inside, that we can also detect the water beneath this vegetation. So we go through the data in Google Earth Engine, which gave us the opportunity to don't download the data, process the data in the platform online. And we use different layers, one from optical, the other one from radar, and also the different polarization in radar. And when we reach this composite, we can see in just one image, we can grab additional data. Okay, we can see the boundaries, and it's somehow obvious that in that lake we have some vegetation. And after creating this composite, we went through using the machine learning to extract and export different classes in this composite image. As we can see, we use 3 layers, and with red, green, and blue. So it gave us this really nice image that, of course, we can see that additional information is coming up. And as output of the processes that had been done in Earth Engine, we can see now we have access to not only the open water in these wetlands, but we can also see the flooded part of the vegetation inside the wetland. So one of the 2 different type of flood vegetation that already detected is by the difference between the radar and optical, and the other type of flooded vegetation with light green color in the image is the area that we have double bouncing. It gives us the opportunity to detect that double bounce with radar and say, okay, if we have the double bounce in the boundaries, that's the area that the vegetation is flooded, and that's the boundary of exactly the water inside the wetlands. And we not only apply this method in one date, we went through 4 months during the last year, from late spring until end of the summer, which is almost 4 months, the flooded months in these wetlands. And we can see different patterns of open water changes and also the flooded vegetation changes. And we also did some accuracy assessment with the runoff to compare this total detected water with the runoff. And we can see that it gave us a good correlation with runoff. And as we can see, from the end of spring, which is almost the flooding season, until the end of summer, which the runoff is going down and the water is going down, the vegetation is coming up. Of course, this is the months that we have in growth season. So the vegetation is also coming up. But we can see the water extent area is going down, which is like the same as the runoff. So water goes down, the vegetation are coming up, and we can see the area that detected as water is also going down. So this could be a good accuracy assessment. We had also some field data because it was not so far from Stockholm, so we grabbed some data and also compare the data with what we had from this somehow, it's not modeling, but it's the assessment on the Earth Engine, which give us these results. And we can see that by applying this method to also other wetlands, we can reach almost 40% of improvement if you compare it to only optical sensors, because they only give us idea about what's on the surface of that object. So we don't have any idea about the water below this vegetation, which is hidden. So if we somehow mix these methods, we can improve the water delineation in our wetlands by almost 40% in some cases. As another example, one of the Baltic coastal wetlands that we can see in this image. By applying this method in this wetland, we can improve the water delineation in this wetland by 43%. And one of the reasons is in these wetlands, we have some areas that we have vegetation. The NDVI is an index for detecting the vegetation based on the optical sensors. And we can see that we have, this index is more than 0.2 in some cases, and this gives us the option that, okay, in this area we have vegetation, and by applying this method, we can detect the water below this sort of vegetation and improve the water delineation. So until now, we have these conclusions from applying this method in different sites in Sweden. And of course, by applying multi-sensor approach, we can improve the water delineation inside our wetlands. Of course, using radar only or optical only should give us some information about the wetlands, but applying the multi-sensor approach could give us additional information about what's going on inside the wetlands. And we can then relate these sort of changes into the effect of Baltic Sea or the nearby atmosphere or environment into the wetlands. And as we saw in some wetlands, the hidden water could account for large amounts of water inside the wetlands. So it's important to detect this hidden water. And of course, using the open source data, as we did, could be helpful for near real-time monitoring, because we don't need to download data, because when it comes to the satellite data, it could be huge. So it's better to do this process online in cloud computing platforms like Earth Engine. And it could be helpful for near real-time monitoring, which is really needed in most cases. And that's it. Thank you. I'm here for questions.
Thank you.